All right, so in question 5, see, here we're given two graphs. We're given a parabola as well as a hyperbola. Now, they tell us that, okay, a point of intersection of f and g, which are the two graphs, they meet at point B. This is our point B. And what is point B? Point B is the turning point of your f of x or your parabola. Now, they also give you the x-intercepts of your f of x graph, and they tell you that, see, it is your y-intercept. So the first question wants us to write down the coordinates of the turning point of f. Now, remember f, which is our parabola, which can be written in a form of f of x is equals to a x plus p squared plus q. And to determine the equation, or rather to determine the coordinates of our turning point, we would need to take our value of p multiplied by -1 and take our value of q as it is. And from here, we would get the turning point. But remember, your parabola is the same thing as your quadratic. The difference is just the manner in which their equations are written. What if they gave you a quadratic and they ask you to determine the turning point? So there is a formula of determining the x coordinate of your turning point in a quadratic, which is minus b over 2a. So you would use this formula, substitute your b and multiply by a negative as well as your a multiplied by 2 to get your value of x. Now, after you found your value of x, how would you find the corresponding y value of your turning point? You're just going to take this x and you are going to substitute it into your original. So y is equals to ax squared plus bx plus c into your original quadratic equation. And after substituting it, you are going to find the corresponding y value of your turning point. But for this example, we have a parabola which its equation is -1/2 x minus 1 squared plus 8. And to determine the turning point, we said we need to take our value of p multiplied by -1. So our value of p, it's -1. And our value of q, it's 8. So the coordinates of our turning point, which is at point B, would be 1 and 8. Now for the next question, they want you to calculate the coordinates of point C. Now what is point C? Point C is the y-intercept of your f of x function. And remember, how do you go about solving for your y-intercept? You need to make your value of x equals to 0. So doing that, y is equals to -1/2 and 0 minus 1 squared plus 8. Plus 8. Your value of x, your value of y should be equals to 15/2. So your coordinates at point C, it's 0 and 15/2. Now they want us to calculate the value of d. Now remember, our g of x function is given in a form of d over x, and this g of x graph, it is our hyperbola, right? So the general equation for your hyperbola, it is your a x plus p plus your q. So because here we do not have anything, obviously our value of q is going to be the same as 0 for our g of x function. But now they want us to calculate the value of a, and here it's indicated by your letter d. But how would I go about doing that? They told me that B is a point of intersection, a point whereby your f of x graph and your g of x graph meet, meaning that this point B is also present on your g of x. So I'm going to substitute it on this g of x graph. And from there, I'm going to try and solve for my value of d. So now doing that, my y at B, it's 8, d, and my x at B, it's 1. So d over 1, it is the same thing as d. Therefore, my value of d is equals to 8. So my g of x function, it's 8 over x. Now, they want me to write down the range of my g of x graph. Now, remember, your g of x is a hyperbola, and always when you're determining range and domains on your hyperbola, you need to take into consideration your asymptotes. But now, for this question, they want the range. So first, I need to identify my y asymptote. And my y asymptote on my hyperbola would be my value of q. But as I've said, on my g of x, I don't have my value of q, meaning that my y asymptote would be 0. Right? So basically, this is the line my graph must never touch. So my y asymptote, it's at 0. Same applies with my x asymptote. My x asymptote, it is minus p. And here, I don't have any value of p, so my x asymptote here would also be at 0. So the asymptotes of my g of x graph are the axis lines. My graph must never touch these lines. Right? Now, to determine my range, okay, as you could see, besides 0, on my g of x graph, I'm not restricted to have any y value. So basically, this graph could be any y value going up, and it could be also any y value going down. So my range is from negative infinity to positive infinity, but remember, my y must never be equals to 0 because this is my asymptote. That line my graph must never touch. For the next question, 5.5, for which values of x would your two graphs? Now, basically, let us try and interpret what does this notation simply means before we can go about trying to answer this question. So here, basically, they want values of x. Your two graphs, remember these two graphs should be attached to one another, f of x and g of x. Your two graphs will be decreasing. And also, they want values of x whereby your two graphs would be decreasing and also be below your x-axis. So this is what we're trying to identify. Values of x for which these two graphs, they are decreasing, as well as values of x for which these two graphs would be decreasing and also be below your x-axis. Now, because there is an equality sign here which says equals to 0, it means that we need to make our x-intercept as our reference point. What do I mean by that? So this here as x is equals to 5, and here at x is equals to -3, which these points are our x-intercepts. We need to make reference to them because this is where our y is equals to 0, and hence here it says equals to, so the two graphs must be less than or equals to 0. So the equals to 0 part simply tells us that we need to make reference to our x-intercepts, which is at -3 and 5, right? We need to represent these 2 points using our x-intercept and also inequality signs. So first, for the first point, we need values of x for which the two graphs are decreasing. Now let me try and identify them on the given diagram here. So this is where the two graphs are attached to one another, or this is where the two graphs meet, right? So if you could see this graph of g of x, it's decreasing. Same applied to your f of x graph. It's going down, it's decreasing, right? So both these graphs there, so both these graphs are decreasing, right? At this point right over here, this is where both graphs are decreasing. It represents this first point right over here. But remember, I said we need to make reference, or our reference point should be our x-intercept coordinates, or our x-intercept x coordinate, which is at 5, right? So we need to represent that, or this point, using inequalities, and our reference should be 5. But then first thing first, I needed to highlight this point. So this first point, it is where both graphs are decreasing. So it satisfies the first definition. Now, what about the second definition whereby both graphs are decreasing as well as they are below your x-axis? As you can see, this is a point whereby the two graphs are below our x-axis. And if you look at this g of x, it starts from here, it goes down, it's decreasing. And also your f of x graph, it's going down. Here, it's decreasing. So basically, this is a region whereby your two graphs are below your x-axis line, and from this point, or from -3, which should be our reference point, going there, as you could see, or going towards the positive, our graphs are decreasing. All right. Now, let us try and represent this in notation form. Let me start with the first point, which is this, and it is for this values of x for which the two graphs would be decreasing. So should our x values be greater than 5 or less than 5? Remember, we're trying to represent this region. Therefore, our x value should be greater than or equals to 5. Now, this would be our first answer. What about for the second answer? For the second answer, should our x values be greater than -3 or should our x values be less than -3? So, as you could see that here, I'm trying to represent this region right over here. So as a result, my x values should be greater or equals to my -3. All right. Now, but remember we had a restriction with regards, because here we have both f of x and g of x. But my g of x has a restriction. It says it must never touch this y-axis line. My graph must never touch this line. It means, okay, my values of x could be less than, my values of x could be greater than -3, right? But at the very same time, this graph shouldn't pass this line right over here, meaning that my x should also be less than 0. Now, because I have a restriction whereby my graph must never touch this y, Remember, this side I'm trying to represent, it's on the left hand side, right? So hence my x, it should be less than 0 to be able to represent this part which is on my left hand side. My x cannot be greater than 0, right? And the reason why I didn't include the equals to sign here is because my graph must never, or my g of x graph must never touch this line. So the second inequality here is x, it should be less than 0. So this would be your first answer. Now let's try and represent this in notation form. X, my lowest value should be this side, which is -3, and my highest value, which is 0, should be this side. So here I said my x, it should be greater or equals to -3, and my x, it should be less than 0. So this is for this second part. Now, for the 5.6 question, they say calculate the values of x so that your h of x, which is minus 2x plus k, will not intersect your graph g. Now, remember your graph g, it is equals to 8 over x. Now, our h of x, it is equals to minus 2x plus this value of k. And now they want us to calculate values of x so that these two graphs would not intersect. So basically, how would we go about doing that? So first step, we're going to equate the two equations together, right? So let me go about doing that. So I'm going to say h of x, I'm going to equate it to my g of x. Now substituting my values, -2x plus k, this is equals to 8 over x. Now I'm going to try and get rid of this x, which is on my denominator, so that this could be in standard form. And I'm going to do the opposite of what it's doing. I'm going to multiply it. And what I do on the left, I must also do on the right. So these two are going to cancel out one another. So I'll get rid of this denominator. Now multiplying this x to the other side, I would have minus 2x squared plus kx. And this is equals to 8. Now I'm going to take the 8 to the other side, 2x squared plus kx minus 8. And this is equals to 0. Now, what is the next step from here? As you could see, this is a quadratic equation. And these two graphs will not intersect one another only if their roots are non-real. Right? And remember, for roots that are non-real, you need to take your discriminant, right? And your discriminant, it should be less than 0. Now, what is your discriminant? B squared minus 4ac. Remember, your discriminant describes the nature of your roots. And if your discriminant is less than 0, this simply means that your roots would be non-real. And as a result, these two graphs would not intersect one another. So let us go about finding those values of k, which would make the two graphs to not intersect one another. So we need to take out our discriminant and make it less than 0. B squared minus 4ac should be less than 0. Now remember your standard quadratic equation, ax squared plus bx plus c. So b is whatever value that is attached to your x. So in this case, k is what's attached to our x. So we're going to say k squared minus 4. Our value of a is going to be -2. And c is going to be minus 8. And this should be less than 0. Now simplifying, -4 multiplied by -2 multiplied by -8, this should be -64. So k squared minus 64 is less than 0. Now I'm going to take this 64 to the other side so that k squared is less than positive 64. And I'm going to get rid of this squared by squaring both sides. Now as a result, this would be plus minus here. And the square root of 64, it's 8. So as a result, our k values, it will be -8 as well as +8. So they would be from -8 to +8. So these are the values of k in which the two graphs would not intersect one another. Now for this question, they say h is a tangent. H is a tangent to G at R, a point in the first quadrant. Now what can I conclude from that? Remember, your first quadrant, its x and y values are both positive, right? So calculate T such that this equation here, it would intersect that graph of G at that point, which is R. So what is the first point that I'm going to try and determine here? I'm going to try and determine exactly what are those coordinates at point R. I know that both my x and y, I expect them to be positive because they told me that R is in the first quadrant. Now if H is a tangent to G at point R, right, it means H and G, they say, because remember your tangent only touches your graph at one point. And what is that point in this case? That point is R. If H is a tangent to G at R, to find this point R, I can just equate the two graphs, my H of X as well as my G of X. And I'm going to find the x value at r, whereby these 2 points touch one another. So my h of x graph, I have minus 2x plus k. Now remember, I solved for k. I said it's either going to be minus 8 or values from negative 8 up until positive 8. But here, what did they tell us? They told us that this point r, it's in this first quadrant. And in this first quadrant, remember, what is k? K, it is your y-intercept. Remember, my g of x is somewhere here. It's like this. And if they say these two graphs are going to intersect one another, right, at this first quadrant, right, it means that, okay, this point r, it's here in the first quadrant. And now, in order to determine whether my value of k here, would it be the negative 8 or the positive 8, it will be because of this statement here. Because this point is in the first quadrant, therefore I know that on my first quadrant, my values of x and y, they are positive. Hence, here, when I substitute k, I'm going to choose this positive 8 right over here instead of the negative 8, right? So my value of k for this scenario, or my h of x, it will be minus 2x plus 8. And as I've said, I'm going to equate this to my g of x. Remember my g of x graph, it was equals to 8 over x. Now from here, I'm going to find that x point that these both graphs share, which is at my point r. Now, from here, I'm going to get rid of this x by multiplying it on both sides, right? So that these cancel out. And this side, I'm going to have minus 2x squared, right, plus 8x. This is equals to 8. So this would be minus 2x squared plus 8x minus 8. This is equals to 0. From here, I can just divide both sides by negative 2, because my negative 2 is my highest common factor here. So as a result, this here, I would have x squared. I would have minus 4x plus 4. This is equals to 0. So that my values of x, they would become negative 2 and negative 2. So my x would be equals to 2, or x is equals to 2. So I know that my r, it's in the first quadrant. Therefore, my x value at r, it will be at 2. Now, what about finding the corresponding y value at r? Remember, I said r is present on both these graphs, your g of x graph as well as your h of x. So I could just substitute this on my g of x, which is 8 over x. I could just substitute 2 to find y, so that my y is equals to 8 over 2, which is equals to 4. And this is my point r, which is in the first quadrant, right? Now, I found my point r. So now they say calculate t such that y, and this is the y at r, by the way, it is equals to your f of x graph plus t. So basically, here it is your y at r and your y at your f of x, right? So basically, your y value at f of x, what would you substitute to find that y value? You need to substitute here. You would, on your f of x graph, you would substitute the x value at r, which is 2. And that y value that you're going to find, you're going to substitute it here, because remember, f of x is the same thing as y, right? Basically, you need your y value here, but at which point? At 2, because this is where your point r is. Now, your y at r is 4. It is equals to, now on my f of x, this is my f of x. If I substitute 2, negative 1 over 2, 2 minus 1 squared plus 8. So let me just punch that into my calculator. 2 minus 1 squared. And this should give me 15 over 2. So this is equals to 15 over 2. And now we're going to solve for this value of t, right? And I'm going to take this negative 50, I'm going to take 15 over 2 to the other side to become negative. And this would be equal to my value of t. So 4 minus 15 over 2, which should be negative 7 over 2. And this would be your final answer.